In this video, you're going to learn how to produce frequency distribution tables. These are tables that summarize raw data and enable one to know how often certain values occur, or how often values in a certain group occur. So more on this shortly. The first thing we're going to look at is the concept of a class. So a class is simply a subset of raw data, and a class can easily be represented or defined using a class interval by stating the interval of the class rather. So we have some numbers here. We have 12, 10, 4, 8. So I can say we have numbers ranging from say 1 to 912. So all sorts of numbers here. So I'm going to define a class, a subset of the raw data. So I'm going to define the following class: numbers from 0 to 10. So this is one class here. I'm going to define another class, numbers from 11 to 21. And I'm going to define another class, numbers from 22 to 32. So I've defined 3 classes so far. So here's the first class, numbers from 0 to 10. So you consider this whole category as a class. The next one is also a class, and so is this. The class interval for the first class is basically what you can see here, 0 to 10. So the interval tells you the lower limit of the class, the smallest number that can belong to the class, and the upper limit for the class, the largest number that can belong to the class. So for this class here, the lower limit is 11. That means that 11 is the smallest number that can belong to this class. The upper limit for this class is 21, and tells you that 21 is the largest number that can belong to this class. So you know what a class is now. You know that a class interval literally just tells you the lower limit and the upper limit of the class. So let's do something. So for the first class, which has a lower limit of 0, the smallest number that can belong to that class, and an upper limit of 10, from the numbers here, these values you see here, which ones belong to this class? Well, let's see. The number 12 does not, 13 does not, so I'll just look for the next number, which is 10. 10 belongs to the class 0 to 10, to this class. And 10 is actually the upper limit of the class, but it belongs to the class. 10 again, 2, 2, 8, 4, 1, 2, 4, 5, 7. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 members of the class from 0 to 10. Okay, there's another one here. There's a 10 here, so that's 12. So there are 12 members that belong to this class. By now, you should get the idea, because if I say which of the numbers belong to the class with the class interval of 22 to 32, you'll know that 28 belongs to that class. So 28 belongs to this class. Let's look for another member. 26 also. Let's see if there are any others. 26 again. 23. So there might be others, so I'm not listing them all out. I'm not marking them out. I'm just showing you that by grouping the data into, by grouping data, it's easier to represent them because you're just summarizing it. So we don't have to write out all the numbers to get the information the numbers are trying to give us. One can group these numbers into classes into class intervals or classes, whichever way you want to put it, and then you might still be able to get the information you're looking for. One thing you need to notice, so we're on class limits now, you know what a lower class limit is and what an upper class limit is. Just to reiterate, the lower class limit of a class is the smallest number that can belong to that class. The number doesn't necessarily have to be in the raw data you're given. The upper class limit is simply the largest number that can belong to a certain class. And one thing you will notice is that an upper class limit and the lower class limit of the next class are different. You can have an upper class limit of 10 here and a lower class limit of 10. So you can't say, oh, I'm defining a class from 0 to 10 and then another class from 10 to 21. You can't do that. The class limits, so the upper class limit of a class and the lower class limit of the next class must be distinct. So just keep that in mind. Next thing we need to look at is the concept of a class boundary. Classes, as you know, have lower and upper limits, and that's easy to understand. But then boundaries can also be defined, and their usefulness will come up later when we go deeper into this statistics course. But just to note, so for the class 0 to 10, the upper class limit is 10. For the next class, 11 to 21, the lower class limit is 11. So what one can do is notice that, for instance, what about numbers like 10.1, 10.2, 10.3, 10.4, 10.5, 10.9, and so on? What class would they belong to? Assuming they would, let's say there was a number like 10.3. Given the class intervals I've defined, which class or class interval, well, which class does 10.3 belong to? None of them, because it doesn't fall into 0 to 10 and doesn't fall into 11 to 21. It's between 10 and 11. So what you can do is notice that there's an interval, or let's say a gap of 1 between this upper class limit and 11 here. So between 10 and 11, there's a gap of 1. 11 minus 10 is 1. So what you can do is take half of the interval between 10 and 11, add that to 10, and subtract it from 11. So what you can do now is say, well, so this class from 0 to 10, I'll just leave this 0 now. Just say the upper class limit of the first class, instead of being 10, is now 10.5. So add, so the interval here is 1. Half of that interval is 1 over 2, which is 0.5. So I'm going to add that to 10, and I'm going to subtract that from 11 to give 11 minus 0.5, which is also 10.5. And then I can do the same thing to this class here. The upper class limit is 21, and the lower class limit of the next class is 22. There's an interval of 1. 22 minus 21 is 1. So numbers like 21.1, 21.2, 21.3 have no class as it stands now. So by dividing the gap between 21 and 22 into 2 halves, I can account for numbers between 21 and 22. So the interval between 21 and 22 is 1. Dividing 1 by 2 gives 0.5. So I'm going to add 0.5 to this upper class limit to give 21.5. And I'm going to subtract 0.5 from 22 to give 21.5 as well. 22 minus 0.5 is 21.5. So I could do the same thing here. So we can just assume I had a lot of classes, and the interval between an upper class limit and the next lower class limit is 1. So I'm just going to add 0.5 to 32 and just stop there. And then for this 0, I could subtract 0.5, and that gives minus 0.5. So these are the new classes. Has 1 with a class interval of minus 0.5 to 10.5. The next class has a class interval from 10.5 to 21.5. And the next class interval has a class from 21.5 to 32.5. So what this means now is, before, for a number like 10.4, it doesn't have any class. It doesn't belong to any of these classes now. But 10.4, now you can say it belongs to this class here. But not a number like 21.9, with these classes, so this one, and this one, 21.9 does not belong to any of these classes. But with the new form, you can comfortably say 21.9 belongs to this class here. 21.9 is between 21.5 and 32.5. So typically what you have is a situation where you have classes, and the upper class limit of a class and the lower class limit of the next class differ by a unit of 1, like just literally 1. So the convention is to divide that 1 into 2 parts, so divided by 2, and then add 0.5 to the upper class limit of the previous class and subtract 0.5 to the lower class limit of the next class, so that you get what we had here. So we're going to have examples that are going to utilize this concept shortly. But the key thing to know is you can have class limits, and with class limits, they might not necessarily account for all possible numbers. But with class boundaries enable you to account for all possible numbers in the raw data. So with class boundaries, you can be sure that every possible number within the range of the numbers in the raw data will fall into a class. With class limits, if you introduce a new number to your raw data, it might be like 10.3 and it will not have any class. But with class boundaries, you can easily say that a certain number belongs to a class. You can be guaranteeing that will happen. So that's the usefulness of a class boundary. So what you note is that unlike class limits where the upper class limit of a class and the lower class limit of the next class are distinct, so 10 is not 11, 21 is not 22, for class boundaries, the upper class boundary of a class and the lower class boundary of the next class can be the same. In fact, they will be the same. That's how it works. The upper class boundary of a class and the lower class boundary of the next class will always be the same. So that's how it works. The final thing we're interested in this section is the frequency of data belonging to a particular class. So for the following classes, which I'm going to define randomly now, so I'm going to have a class, and in this class, its class interval is such that the lower class limit is 1 and the upper class limit is 10. The next class will have a lower class limit of 11 and an upper class limit of 20. The next class will have a lower class limit of 21 and an upper class limit of 30. So we have 3 classes here, and I'm still utilizing this raw data except for this 10.3. Now for the first class, for this first class, which has a class interval of 1 to 10, what is the frequency of the data belonging to this class? What's the frequency of numbers that belong to this class from the raw data set that has been given? I'm just going to draw a mini table with 2 columns. The first column has the classes or the class intervals of the classes. So I'll just write class for this column. And this column has the frequencies. So I'll just shorten that with let's just fill it in. Frequency, write the full form. So this column or this table will have 4 rows. So for numbers, the question is, how many numbers in the raw data are in the following class with the class interval of 1 to 10? Well, we did that earlier. For numbers between 1 to 10, let's count. So I'll use a different color to circle them. I'll use white to circle them. So let's scan through. So 10. Okay, we already did that in black. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 numbers belonging to the first class. So 12 numbers. So the frequency of numbers in this class is 12. How about from 11 to 20? So the frequency of the class with the class interval 11 to 20 is simply the number of times numbers belonging to this class appear in the data that's been given. So here's 1, 2, 3. So by the way, I'm saying 12, 13, and 14 belong to this class. 12, 13, and 14 are between 11 and 20. Okay, so that's 3, 4, 5, 6, 7, 8, 9. So there are 9 numbers in this class. So then the frequency of this class is 9. And finally, for numbers between 21 to 30, we need to determine the frequency of numbers in that range. So let's scan through. So 28 falls in that range. So that's 1. 26 falls in that range. So that's 2. And that's 23. It falls in that range. So that's 3. So there are only 3 numbers between 21 and 30. So the frequency of the class with a class interval of 21 to 30 is 3. I'll show that in black. From this introductory video, you know what a class is. You know that a class has a lower limit and an upper limit. So by specifying a lower limit and an upper limit for a class, what you're doing is you're specifying a class interval. The interval tells you the lower limit and the upper limit and says, well, the numbers belonging to a certain class must fall between the class limits, but the lower limit and the upper limit of a class are also members of a class. So for this first class here, this is a class here. The class interval is from 1 to 10. The lower limit of the class is 1 and the upper limit of the class is 10. We also looked at frequencies. The frequency of a class just tells you the number of times data belonging to that class appears in the raw data set. So in this case, we had some numbers that are given to us. And for the class 1 to 10, we figured out that only 12 out of all the numbers here belong to the class. So the frequency of this class is 12. A similar idea was applied to the other classes, and we found out that the frequency of this class is 9 and the frequency of this class here is 3. Finally, we looked at class boundaries, which may be slightly confusing at this point, but you find them easy to understand once you start seeing how they're useful. So I told you that in the current form, to look at these classes here, 1 to 10, 11 to 20, 21 to 30, so we have 3 classes. If a certain number like 10.3 was added to this data set, which class does it belong to? Does it belong to the first class with a class interval of 1 to 10? No, it doesn't. And it doesn't belong to the next class between 11 and 20. 10.3 falls between 10 and 11. So what you do is say, well, the interval, or the difference between with this upper limit, so the upper limit of a class and the lower limit of the next class, in this case is 1. That's the difference. So you take half of that difference and you add it to the upper limit of the preceding class, and you subtract it from the lower limit of the class that follows. And then when you have a situation like this where you have the upper class boundary of a class and the lower class boundary of the next class being the same. So we'll have more on this later, but by mentioning it here, I'm just introducing you to the idea of a class boundary. So note the distinction between class limits and class boundaries.